Hi everyone, in this video we will discuss about the transient stability analysis of IEEE 9 bus system. So the objective is to do the transient stability analysis, and we will be using a TSAT module of DSA tool software for this particular experiment. So for the dynamic modeling of generators, we need different data like generator, power system stabilizer, governor, exciter, whatever components we are using, we should have the data. So all these data are given in the manual. In this particular system, we are using power system stabilizer, governor as well as exciter. So the data is given here. You can use this for to model the dynamic system. So click on TSAT, click on file, new, click on create a new TSAT case, then next. So prior to the TSAT simulation, you should have done the PSAT simulation of the system. uh, so you can go to browse and select the file, PFB file, the particular PFB file. So we have already done the PSAT of IEEE 9 bus system, and we have saved it as IEEE 9 bus system. Select that one and click open. Now the power flow format should be PFB, as our file is in PFB format. Then you can select solve base power flow before simulation. Click on next. So dynamic data, here we don't have the dynamic file with us, as we are doing it from scratch. Like if you already have a file, you can go to browse and input that dir file here. If you don't have one, click on create. Then you can see different models here. So this DG0, a model starting with a name DG0S means it's synchronous machine. So uh, we can select, let's say, DG0S4 for bus number 1, and click on search, select the bus number, then input the data of bus number 1. These data are already there in the manual, so you can refer there. um, 3615, XQ is 0.24, XL is 0.06, X dash D is 0.1508, X dash Q is 0, X double dash D is 0.1, then 0, 9.96 torque, then 0, 0.05, 0.05, inertia is 7.38, and 1.6, alpha 0, 1.01, 1.02, and finally the model should be in. Click OK. Now our bus 2 should be modeled as DG0S5. So click on search bus number 2, then 310, 0. So the difference between DG0S4 and S5 are based on the saturation model we are selecting in while modeling the system. 0.37, 0.21, 0.27, 6.4, 0.535, 0.05, 0.05. Inertia of this machine is 2. Then alpha 0, 1.01. Then model should be in. Click OK. Now the third machine is also modeled as with model DG0S5 only. So in order to add one more generator to the same model, you should right click here and click create new from selection, and then search, select the bus number, then change the parameters to 80, 1.68, 1.61, 36. Next dash is 0.2321. Next dash of Q 0.032, 0.27, 5.89, 0.6. Click OK. So we have now added all the generators. Now next one is power system stabilizer. So the model we have to use is PSS9. So in this list you have to select PSS9, click on create new model. So basically you have to right click and select create new model, search bus number 1, then add the parameters. I type is 0, N1, M5. So the particular model is also given here, and if you have in case if the model is not here, you can go to TSAT model manual also for uh, to see the model. 0, 0, 0.15, 0.03, 15. Once it is done, click OK. Now we have two more power system stabilizers. So again click here, then right click, create new from selection, select the bus number and change the parameters. So all the power system stabilizer parameters are similar, so we can use the same, like there is no change. Just click OK. Then again we have to create one more for bus number 3. Click OK. So we are done with power system stabilizer. Then Next one is governor. So governor model is GOV9. Create new model, then search for bus number 1, uh, input the data. Again, there should be two more for the rest of the generators. Then the parameters remain same for all the other generators. That's why I'm not changing any values. Then we have one more for bus number 3. Click OK. Then now we have exciter. Exciter is EXE1. So select the bus, then input the parameters. Model should be in. So then again two more for bus number 2 as well as bus number 3. So we are done with the dynamic modeling. Now we have to save this file. So for that, click on save. We can give the name as IEEE 9 bus system. Click on save. Now next, monitor data. So again we will create one new monitor data. We have to let's say we have to monitor generator frequencies. Either you can go add generators individually, or else click on here in generator by area zone or system, click on add system uh, from MVA 0. So that means all the total system will be added here. So click OK. Now again we can we have to observe the bus frequency and those things also. So click on add system, up to so the limit is given as 0 to 999 kV. So if you remember, we have a bus having the maximum kilowatt of 3 230. So we are within limits, so click OK. Then voltage frequency and voltage frequency rate should be selected. Here again, rotor frequency rate, field, mainly it should be rotor frequency rate and field current you can select. And if you have any renewable bus, those frequency can also be selected. uh, Anyway, I'm selecting all. Click OK. Then save this monitor file. If you want to monitor any more parameter, you can always come back and edit this file. So as of now we have done this much. Now next we will go to next, contingency data. So the contingency is specified as generator at bus 3 tripping after 5 seconds of simulation. So uh, click on create a customized contingency using the contingency editor. Click OK. We can give the contingency name again as it can be gen 3 tripping. Tripping. Simulation length can be, let's say, 50 seconds. Then our aim is at 5 seconds generator 3 should trip. So go to simulation at time 5 seconds. Okay, so the command is here at time 5 seconds, generator, disconnect generator, search generator 3, click OK. So disconnect generator 3 with ID 1, generator at bus number 3 ID 1. Click OK. We have to save this file. IEEE 9 bus system contingency. Save. Now we have few more optional data that can be that need not be added as of now, so we can skip those steps. And so the title, if you want, you can change, or else we can keep it as base scenario. Click next. Save this TSA file as again IEEE 9 bus system. Click on save. Now go to run base case analysis. uh, so you can see the result here, like if the system is insecure, you can see it in the status itself, it will be insecure. Now for the detailed analysis of result, go to view result. Then so this is DSA tool, DSA tools output analysis module. Here you can see the various simulation output. So scenario, we have only one scenario, that is base case scenario. Then contingency, as of now we have only one. If you have multiple, you can select it from here. Same for scenario also. Now the quantity, you can monitor any quantities. Let's say we will start from generator speed. Click on select that particular quantity, then click on plot. You can see we have generator 3 tripping. So generator 2 and 1 frequency is varying from the 60 hertz frequency, and it is settling to some other frequency. As we are not uh, reconnecting the generator. So similarly you can see all other system parameters, let's say bus frequency, like that. So we are done with the TSAT simulation of IEEE 9 bus system. Thank you.